Hi guys, this is Lalima, and in today's video we are going to see how we can load multiple zip files from nested directories into a single data frame. Here you can see I have one diagram where inside one folder there are multiple subfolders. Inside those subfolders again we have multiple subfolders, and inside those folders we have multiple zip files. To understand this logic properly, I have taken one data set. This is a sales data set for 2009 year. And inside that, if you see, it has total 12 folders, one folder for each month. From 1 to 12 means from January to December. And inside those folder again we have multiple subfolders which is represent the random dates for the particular month. So if you see, currently I'm inside 05 means I'm inside May folder, and it has random dates from that May month. Okay, and if we go inside any random date, then that particular date has around 310 zip files. Okay, so we can say inside that folder we have 12 folders. Each folder contain on an average 4 subfolders, and those subfolders contain 310 files. Okay, so in this video we are going to read around 15,000 zip files, and suppose each file has around 100 number of lines or 100 number of rows. So in this case we are going to load, let me copy this, we are going to load around 1.4 million rows or 1.4 million records in our single data frame. So this is a huge data set, and we are going to load this huge data set from multiple zip files which are present inside the nested subdirectories. So here, to understand the logic properly, I have created one demo data set from this original data set. Inside this sales demo data set, instead of 12 folders, I have taken only 2 folders. Each folders contain 2 subfolders, and each subfolders contain only 2 zip files. So I have taken very small data set so that we can understand logic properly, and once we implement or understand this logic, then we implement the same logic over the larger data set. Okay, so let's start to load our data. First, we need to import pandas module. So import pandas as PD. Okay, if you see that our demo data set present inside desktop, then inside file. So let's first save this path into a variable equal to, it's inside desktop, then files, then 2009 sales demo. Okay, so we have saved our path inside a variable. Okay, next thing what we want, first just open this path or check whatever the available files and folder this path contain. Okay, so check all subfolder or subdirectories / files inside that path. After that, whatever file you find, just check whether it's a zip file or not. Okay, so check ggif files. Okay, ggif files inside that folder. Once you get all the zip files, then unzip those files. Okay, then load or read those files into a data frame. So this is our task. So first we already get the demo dataset path. First we check all the subdirectories of files available inside that path. Okay, so for that we use for loops. So for check path, check subdirectories, check files inside os.walk, and here you need to pass the path. So path is path underscore directory, and whenever you get any file, just check its name. So for name in files, and if that name ends with .txt.ggif, because here you can see inside our sales demo data our file ending with .txt.ggif. Okay, so if that file ends with, suppose if name dot ends with .txt.gg, then just save that file path into a variable. So our target file would be os.path.join, and here you need to pass the name of that file with its respective path. Okay, and if we print that tar file, so you can see here I'm using OS module, so first import OS as well. So import OS, and if we run this, then here you can see inside that path it's checking all the paths, subdirectories and files. Whenever it's finding any file name, it's checking whether that file name ending with .txt.ggif or not, and if that file ending with that particular regular expression, that it's printing that file name with its respective path. Okay, so in our first step we checked all the subdirectories. Here you can see 2009 sales demo data. Inside that there is one folder 01 or 02. Inside that again we have subfolder 1_1, 1_2, 2_1, 2_2, and all these subfolder contain multiple zip files. Okay, so we displayed all the zip file with their respective path. Now next thing is we want to unzip those files. Okay, so here you can see, let me copy this. Okay, now to unzip this file we use gzip.open module. Okay, so here we see with gzip.open, and we already saved that file into this variable, so here pass that tar file, and after unzipping that file we want to read that file, so here you pass mode equal to read, and there are two type of mode, one is binary mode and second is text mode. So we want text mode, so here you need to pass read with text mode. Okay, and just save this as a gzip file object. So here give any object name, so I'm giving here f1, and if you want to know more about this, just click here and shift plus tab. So here you can see it's give you detail about gzip.open module, and here you can pass file name and you need to pass the mode name. Okay, so here in mode name there are two things, binary mode and text mode. We only want to read that file in text mode, so that's why I passed here RT. Okay, and once this file unzip, it create gzip file object. Okay, and that zip file object is input output text wrapper, and we print this object. So here you can see it's a text input output wrapper. Okay, so even though it's unzipped now, but we cannot load this input output text wrapper into a data frame. Okay, so just comment this, and before loading that object into a data frame, first convert into input output string object to read that file. So for that just give any random name equal to io.string io, and inside that pass that wrapper object, and we want to read that file, so just call the read function. Okay, so here you can see we first checked all the files. If those files ends with .txt.gz, then just save that file path into a variable, then just unzip that file and read that file into a text mode and create a text input output wrapper object. But this is a wrapper object, that's why we cannot directly load into a data frame. So before that, first we need to convert into a string object. So we have called IO module, where we use the string IO function, and we want to read that object, so we pass f1.read function. Okay, so here we use IO, so first import IO as well, so just include it here, and it's done. And if we run this, so it ran successfully. And now if we check the data, so just call print, inside that pass data. So here you can see now it's converted into a string input output object. So now we are ready to load this data into data frame. So for that just call data frame equal to pd.read_csv, and inside that pass data. And if we run, then let me first comment this, and if we run this, so here we are getting an error. So error tokenization expected error. Okay, here we need to pass separator as well. So if you see here, this is my file inside this 2009 sales demo data. So if we unzip one file, extract here. Okay, so if we open this file, here you can see it using tab as a delimiter. Okay, so here you need to pass as a separator as well. So separator equal to, it's using as a tab. So if we pass like that and run this, so it loaded successfully, and we can check our data frame. So check data frame dot head, and here you can see our data now loaded into data frame. Okay, but this is a for loop, so currently this data frame contain only this last file data. Okay, because it's using for loop and it overwriting the previous file. So if you want to load all these files into a single data frame, so first you need to create empty data frame, and then we concate it with the existing file. Okay, so first just create an empty data frame. So I'll give a final data frame equal to pd dot data frame. It's our empty data frame, and we want to concat this final data frame with our data frame. Okay, so final df equal to pd dot concat, and here just pass final df with this data frame. Okay, and we also want our indexing in sequence, so just give ignore underscore index equal to true. Okay, so now if we run, so it's loaded successfully, and if we check this final data frame, so you will see our data now loaded, and we can also check the shape of this final data frame. So currently it has 865 rows. Okay, so on an average these files contain 100 rows, and here you can see there are total 8 files. So our final data frame contain the approximate rows as per our expectation. Okay, so this is the way using that we loaded our 2009 sales demo data set into a data frame. Okay, but the same thing we want to apply over a larger data set, and we already calculated that there are around 15,000 zip files which we want to read or unzip, and there are 1.4 million rows which we want to load into our data frame. So this is a huge data set, and we want to know how long our script will take to load this much data. Okay, so here we can include the timer. Okay, so just before final data frame, we need to include start time equal to date time dot now, and after our script complete, then just note down the end time date time dot now, and display the total time, which is end time minus start time. Okay, and here we are using datetime module, so we need to import first datetime module. So from datetime import datetime. Okay, so it's running fine. Here you can see it took 0.16 seconds. Here I also want to know how many files it unzip and loaded into data frame. So for that I'll just initialize count. So just give count equal to 0, and after this final data frame concat, just increment that count equal to 1. Okay, and if we print it here, print total file loaded, and here pass the count. Okay, similarly I'm doing here print total time taken, and here just pass this end time minus start time. So if I run this again, so here you can see it took 0.15 seconds and total 8 file loaded, which is correct as per our demo data set. Now our demo data set loaded properly as per our expectation. So the same thing we'll do with our original data set. And here you can see this is our original data set, which is 2009 underscore sales. So here in path only, I'm just modifying this sales demo data set with original one. So I'm just removing this demo, and now this is the path for our original data set. Okay, so I'm running this again, and this is working fine. And if we run this again, then it will take some time, so I'm just fast forwarding it. Okay, so our code now completed, and if you see here, it took 2 hours 48 minutes and 5 seconds to load 15,770 files. So it is too much time to load this much data, and I'm using my local system, so my RAM and processor could also cause this much delay. So simultaneously I also ran the same code in different system, so we'll also see that how much time that system took to load this much files. Okay, so now if we see our final date frame shape, so here you can see it loaded 1.5 million records, which is similar like what we have calculated earlier. So it unzipped around 15,000 files and loaded 1.5 million records. And if we check the head of our final data frame, so it loaded correctly. Okay, now if you see, I'm on my different system and I ran the same code and uses the same data set. So here you can see it took 2 hours 12 minutes and 20 seconds to load 15,770 records. Here I use the same data set, that's why records are same. And if we check the final data frame shape, so here you can check the shape and see it also have 1.5 million records. Okay, so you can easily see the difference. In my first system it took 2 hours 48 minutes and here it took 2 hours 12 minutes to load the same data set. So we can say that our RAM processor configuration matters for your performance. Okay, and I hope in cloud system it perform much better. So let's check data as well. So if I see head, so here also our data loaded properly. Okay, let's also do one more thing, save this data frame into a CSV file. So just give final data frame dot to underscore CSV and give the path and name of that file. Okay, so it's inside current directory, then 2009 sales. So I'm just giving the same 2009 underscore sales, and inside that folder I want to create my CSV file. So I can give sales dataset dot CSV. Okay, and if we run this, so it takes some time. Okay, so if you see here, our data frame now saved into our CSV file. So we can go inside and here you can see sales underscore dataset dot CSV. So if we open this, then here you can see this file also has 1.5 million records. Okay, so the reason behind saving this data frame into a CSV file, that we already seen that if we are loading data from GIF file which is already in nested directory, it taking too much time, right? It's taking around 3 hours. Okay, so what if we are loading the same number of records from a CSV file directly into a data frame? Okay, so that's why I've saved this data into a CSV. Now let's see how long it take to load that 1.5 million records from that CSV to data frame. Okay, so for that I want to check the time, so I'll just copy this first. Okay, and this also. Okay, and in between give any data frame name, so data frame new, and give this name, and here pd dot read underscore CSV, and here just pass that path. So this is our file. Okay, and if we run this, then let's see. So here you see it took only 6 seconds. Okay, so let's check the number of rows as well. So just copy and dot shape, and yes, it has 1.5 million records. Okay, so in today's video we have seen how we can load multiple GIF files from nested directories into a single data frame. If you have any question, doubt, or know any optimized way to do the same task, then please do comment. Also share your experience, how long usually your system takes to load this much data into a data frame. Also, if you want to know about any other topic or any other scenario, then please do comment. We will try our best to make videos on those topics. So that's it for today. We'll see you in next video. Till then, bye and take care.